A stock goes up 50%. Then it goes down 50%. The arithmetic mean of those returns is 0. But your actual portfolio, it is down 25%. $100 became $150, then dropped to $75. The arithmetic mean just lied to you. And on the CFA exam, that lie is worth multiple wrong answers. The gap between arithmetic and geometric mean is not a rounding error. On a $100,000 investment over 30 years, it is the difference between $2.09 million and $2.97 million. $875,000. One formula swap. Start with the simplest mean, the arithmetic mean. Sum every observation. Then divide by n. Written as x bar equals the sum of x sub I divided by n. The CFA exam uses this for one specific job: estimating a single period expected return. If someone asks what return you expect next year, arithmetic mean. If they ask what return you earned over multiple years, stop. Do not use this formula. The trigger word is single period. Lock that in. Here is why the arithmetic mean fails for multi-period returns. Take 3 annual returns, plus 10 minus 5 plus 20. Arithmetic mean, add them, divide by 3. 8.33%. But your money did not grow at 8.33% per year. The geometric mean tells the truth. Multiply 1.10 by 0.95 by 1.20. Take the cube root. Subtract 1. 7.84%. The difference is not rounding error. The minus 5% year compounds against you. It shrinks the base for the following year's 20% gain. The exam always includes a negative return year to maximize this gap. Geometric mean is the only correct answer for multi-period performance. There is a third mean the exam tests that most candidates underestimate: the harmonic mean. It appears in at least 1 or 2 questions per exam sitting. Here is when to use it. An investor puts $1,000 per month into a stock. Month 1, price is $20 per share. Month 2, price is $25. Month 3, price is $10. The arithmetic mean of prices is $18.33. But how much did the investor actually pay per share? Divide total dollars by total shares. 3,000 divided by 190 shares equals $15.79. Harmonic mean formula: n divided by the sum of 1 over each price. 3 divided by 0.19 equals 15.79. Exact match. The trigger phrase on the exam is always equal dollar amount. Equal dollar amount equals harmonic mean. Every time. Now the concept that trips up more candidates than any other in this reading: population variance versus sample variance. The formulas look almost identical. One divides by n. The other divides by n-1. Here is why, not just the rule. When you compute the sample mean x bar, you have already used one piece of information to estimate the true mean. The sample mean is guaranteed to be closer to the observed data than the true population mean would be. This compresses the deviations. It underestimates the true spread. Dividing by n-1 corrects for that compression. n-1 is called Bessel's correction, and it represents degrees of freedom. You had n observations, but you spent 1 estimating the mean. The exam signal. The word sample in the question stem means n-1. The words population or all mean n. Read the stem first. Every time. 2 more formulas that share the same denominator logic. Standard deviation is simply the square root of variance. Same n versus n-1 rule applies. The coefficient of variation, CV, is the risk efficiency metric. Standard deviation divided by the mean. Not the other way around. CV tells you how much risk you take for each % of return you earn. Portfolio A, standard deviation 15, mean return 12. CV equals 1.25. Portfolio B, standard deviation 9, mean return 8. CV equals 1.125. Portfolio B is more efficient, less risk per unit of return. The exam trap. Candidates pick Portfolio A because it has higher absolute return. That is the wrong answer. Always compare CV. Lower CV wins. Skewness is one of the most commonly confused topics in CFA Quant. Here is the single fact that unlocks every skewness question. The mean is pulled toward the tail. Positive skew right-skewed has a long right tail. Extreme high values pull the mean upward and to the right. So mean is greater than median, which is greater than mode. Think of income distribution. Most people earn below the national average. A few billionaires pull the mean up. That is positive skew. Negative skew left-skewed has a long left tail. Occasional catastrophic losses pull the mean DOWN. Mean is less than median, which is less than mode. Options writing strategies. Most months bring small wins. But occasional disasters drag the mean below the median. Exam signal. If mean is below mode, the distribution is negatively skewed. If mean is above mode, positively skewed. Start with the mean to mode relationship. Long-term capital management had Nobel Prize winners running their risk models. Their models said a 10 standard deviation loss event was essentially impossible. A 1 in 10 to the 24th probability. In 1998, they lost $4.6 billion in less than 4 months. The reason? Their models assumed a normal distribution. Actual financial returns are leptokurtic. Fat tails. With extreme events happening hundreds of times more frequently than normal models predict. Leptokurtic means excess kurtosis greater than 0. Excess kurtosis equals kurtosis minus 3. The normal distribution has kurtosis of exactly 3. Fat tails on both sides. High center peak. Less probability in the shoulders. Platykurtic is the opposite, excess kurtosis less than 0. Thin tails. Flatter peak. The exam trap. Candidates think leptokurtic is dangerous because of the high peak. Wrong. The danger is always the fat tails. The Sharpe ratio ties everything together. Excess return divided by total portfolio standard deviation. RP minus RF divided by sigma p. The numerator is excess return, portfolio return minus the risk-free rate. Not total return. Excess. If portfolio return is 12%, risk-free is 4%, and standard deviation is 12.3%. Sharpe ratio equals 8% divided by 12.3% equals 0.65. Think of this as a coefficient of variation for excess returns. You earn 0.65 units of excess return for every unit of risk taken. The exam trap. Candidates use total return in the numerator. That gives 12 divided by 12.3 equals 0.98. Wrong. Always subtract the risk-free rate first. Higher Sharpe ratio equals better risk-adjusted performance. Always. Exam question. An analyst observes annual returns of 10%, minus 5%, and 20% over 3 years. The geometric mean annual return is closest to A. 8%, B. 7.84%, C. 8.33%. Answer is B. Geometric mean equals 1.1 times 0.95 times 1.2, all raised to the 1/3 power, minus 1. That product is 1.254. The cube root is 1.0784. Subtract 1, 7.84%. Choice C, 8.33, is the arithmetic mean. Choice A, 8, is a common rounding distractor. The exam always includes a negative return year to maximize the gap between the two means. Negative return year in the STEM equals geometric mean question. Every time. Next question. A sample of 10 monthly returns has a sum of squared deviations from the mean of 0.0045. The sample variance is closest to A. 0.000045, B. 0.00005, C. 0.0005. The answer is C. Sample variance equals sum of squared deviations divided by n-1. 0.0045 divided by 9 equals 0.0005, which equals 0.0005. Choice A, 0.000045, divides by n equals 10. That is the population formula. The word sample in the question stem is your trigger. Sample means n-1. If the question had said population or all 10 returns, you would divide by 10. Read the stem. Find the trigger word. Then compute. Third question, this one trips up candidates who rely on intuition. A return distribution has a mean of 8%, median of 9%, and mode of 11%. This distribution is best described as A. Positively skewed, B. Negatively skewed, C. Symmetrically distributed. Answer is B. Negative skew. The mean 8 is below the mode, 11. Long left tail, pulling the mean DOWN. Order for negative skew, mean less than median less than mode. Here, 8, 9, 11. Confirmed. The trap, many candidates think positive values mean positive skew. Wrong. Skewness is about the direction of the tail and where it pulls the mean. Mean below mode equals negative skew. Mean above mode equals positive skew. Use those two anchors. Fourth question, straight from the official curriculum. For a dataset with unknown distribution, Chebyshev's inequality states that at least what percentage of observations lie within 2 standard deviations of the mean? A. 68%, B. 75%, C. 95%. Answer is B. 75%. Chebyshev's formula, 1 minus 1 over k squared. For k equals 2, 1 minus 1/4 equals 75%. The traps are choices A and C. Both come from the empirical rule for normal distributions. 68% is the 1 sigma normal rule. 95% is the 2 sigma normal rule. But Chebyshev works for any distribution, normal or not. The exam trigger is the phrase unknown distribution or non-normal. That phrase means Chebyshev, not the empirical rule. Screenshot this. Every trigger word, every formula, every trap, on one page. Central tendency decision tree. Multi-period compound returns, geometric mean always. Equal dollar amounts at varying prices, harmonic mean always. Single period expected return, Arithmetic mean. Skewed data or outliers, use the median instead of any mean. Variance decision. The word sample means divide by n-1. The words population or all mean divide by n. Skewness anchors. Mean above mode, positive skew, long right tail. Mean below mode, negative skew, long left tail. Kurtosis. Excess kurtosis above 0. Leptokurtic, fat tails, higher extreme event probability. Excess kurtosis below 0. Platykurtic, thin tails. Sharpe ratio. Always subtract the risk-free rate before dividing by standard deviation. CV and Sharpe, both are risk per return metrics. Lower CV is better. Higher Sharpe is better. Chebyshev trigger, unknown or non-normal distribution. Formula, 1 minus 1 over k squared. Six steps for every descriptive statistics question on exam day. Step 1, read the question stem before anything else. Locate the trigger word. Sample, population, multi-period, $, unknown distribution. That word determines your formula. Step 2, for central tendency. Is the data skewed or does it mention outliers? Median. Is it rates of return over multiple periods? Geometric. Equal dollar amounts at varying prices. Harmonic. Otherwise arithmetic. Step 3, skewness direction. Find the mean and the mode. Mean above mode equals positive skew. Mean below mode equals negative skew. Do not guess from the values themselves, use the relationship. Step 4, kurtosis. The word excess means subtract 3 first. Positive excess kurtosis, leptokurtic, fat tails. Negative, platykurtic, thin tails. Step 5, CV questions. Compute sigma divided by mean for each option. Pick the lowest. Sharpe, excess return divided by standard deviation. Pick the highest. Step 6, time budget. Geometric mean calculations are the most time-intensive. Practice the keystrokes until the formula is automatic. Budget 90 seconds maximum per quant question. Every formula in this reading is on that cheat sheet. But formulas alone are not what fails candidates. It is the trigger words. The exam never says, calculate the geometric mean. It says, an investor earned the following returns over 5 years. You must recognize that 5 years and annual returns means geometric mean. The exam never says, use Bessel's correction. It says, a sample of 12 observations. You must recognize that sample means n-1. Master the trigger words, and the formulas become automatic. The next lesson in this series covers probability distributions, where normal, binomial, and log normal appear on the exam, and exactly when to use each. The playlist is in the description.